In the next two videos, we'll prove the formula for centripetal acceleration, namely that the magnitude of the acceleration towards the center of the circle for uniform circular motion is the magnitude of v squared over r. First, we'll outline the proof. Step 1 will be using some basic trigonometry of the circle to express the vectors for position and velocity in terms of the x and y coordinates of the particle. This argument will be a little bit heuristic, as arguments tend to be in physics, but hopefully you'll be convinced that each step is correct. Next, we'll take the derivative of this velocity vector v to get the acceleration vector a. And finally, we'll look at a, and its magnitude and direction will be pretty easy to calculate, it turns out. So these are the three steps we'll take to derive the formula for acceleration in uniform circular motion. So let's start out by drawing this quarter circle here. And here we see that for any angle theta, we have a corresponding x coordinate of the particle and a y coordinate of the particle. This function will come in handy later. Now let's express the vector x that represents the position of the particle in terms of two components. One is how the x component of the vector is changing with theta, and the other is how the y component of the vector is changing with theta. Expressing it this way will make deriving v easy. From trigonometry, since x over r, the radius of the circle, is cosine of theta, you can see that the x component of the vector is r cos theta, and similarly the y component of the vector is r sine theta. With this setup, deriving v is pretty easy. The x component of the vector v is the rate at which the x component of the vector x is changing with theta, and similarly for y. So the x component of the vector v, it turns out, will be proportional to the derivative of cosine, which is negative sine theta. And the y component will be proportional to cosine of theta. Now, I told you our argument would be a little bit heuristic, but hopefully this step isn't hard to believe. The magnitude of the vector v is, well, v. So the full vector v is actually negative v sine theta for the x component and v cos theta for the y component. But now, again, using trigonometry, sine is just y over r, the radius of the circle, and cosine is x over r. So this is the final expression we have for v. In the next video, we'll continue the proof starting with this expression.